ultimate example. This guy, what's the probability of x is 0? So this is marginal probability. We don't care about y. So imagine I compress this table. So that means I sum these two numbers, 0.2 plus 0.4, which is this line. What's the probability of x is 1? This number plus this number, which is 0.4, which is this one. What's the probability of y 0? We do not care about x. That means we collapse the table along the x direction, compress the table on this direction. So we sum these two numbers and sum these two numbers. Sum these two numbers give us the y equals 0 probability, which is this one. And sum these two numbers give us the y1 probability 0.4. Expected value, so it will be the value of x times the marginal probability of x is 0 plus the value of x is 1 times marginal probability that x is 1, which will be this number multiply the sum plus this number multiply the sum, it will be 0.4. Now this guy, expected value of y, it will be the value of y equals 0 times the marginal probability y is 0 plus value y1 times the probability y is 1. So it will be y0 times the sum plus y1 times the sum, it will be 0.4. Now this guy, exy. So recall the expected value of fx, it will be the sum of f small x times p small x. So we have fx become xy. Probability is the joint probability of xy. So it will be the value of this xy times the value of this pxy. x0, y0 multiply the occurrence probability x0, y0 plus x0, y1 times the probability of x0, y1 plus x1, y0 times the probability of x1, y0, and lastly x1, y1 times the probability of x1, y1. This number is 0, so everything multiplied 0 is 0. Okay. There is a 0, so everything here is 0. There is a 0, everything here is 0. This one, this is not 0, but probability of x1 joint y1, that means this box is also 0. So therefore, the expected value of seeing xy multiplied together is 0. This is the covariance of x and y. So by a formula can be written as the expected value of xy minus the product of ex, ey. So we know that expected value of xy is 0, and we also know the expected value of x and also the expected value of y. So we can compute them like this, and this value is not 0, meaning that xy are not independent. The variance of x, it will be the value of x subtracting the expected value, whole thing square, multiply the occurrence probability, and then also 1 minus the expected value, whole thing square, multiply the occurrence probability, and the whole thing take a sum. So it will be this expression, variance of y. Variance of y will be the value of y0 minus expected value of y, take the square, multiply the chance y is 0, plus 1 minus expected value of y, take the square, multiply the chance y is 1, which will be this expression. So correlation coefficient is covariance divided by the square root of variance. Covariance, we know that is 0.16, so we have 0.16. And for these two numbers, we already have that both of them are 0.24, so it will be 0.24. Don't forget there's a square root, okay? And this number give us 0.66. It is a positive number, so it means if x increase, probabilistically speaking, y have a tendency to increase. Now this guy, this is the conditional probability that x is 0 given that y is 0. By definition, condition is joint divided by marginal. So we consider the joint probability of x0, y0 divided by the marginal y0. x0 joint y0 is this box, so it's 0.2. Marginal of y0 means we don't care about x, so we add everything on y equals 0. So it will be 0.2 plus 0.4, so it will be 0.6. Calculate this is 1/3. The conditional probability of x1 given that y equals 0. We previously just computed the conditional probability of x0 given that y is 0. So we just use 1 minus, we can get the solution. Or you can start by definition using the joint of x1, y0 divided by y0, it will give you the same thing. The expected value of x given that y is 0, it will be the value of x multiply the conditional probability of x0 given y is 0 plus x is 1 times the x is 1 given that y is 0. We already have both these numbers here. So first of all, this is 0, so we get this 0. And 1 times whatever value is that value. And this particular value is 0.66, so therefore we get 0.66. The conditional probability of x equals 0 given that y is 1. By definition, this is the joint x0, y1 divided by the marginal y1. So joint x0, y1, joint x0, y1 is this number, 0.4. And marginal y1 means we don't care about x, we only care about y1, so it will be the whole column, which is 0.4, so it's 0.4 divided by 0.4, which is 1. That means, given that y is 1, 100% of the chance x is 0. The conditional probability of x1 given that y is 1 will be 1 minus the opposite, that is, condition of x0 given that y1. Previously, we know that this guy is 1, so 1 minus 1 is 0. So, in other words, given that y is 1, the chance that x is 1 is 0. And if you look at this table, given that y is 1, there's nothing on x1. So therefore, this is saying that if we know that y is 1, it's 0 chance x is 1. The expected value of x given that y is 1, it will be what? It will be the value of x that is 0 times x is 0 given that y is 1 plus x is 1 times x is 1 given that y is 1. So it will be this value times this probability plus this value times this probability, which is 0. So what does it mean? It means if we know that y is 1, on average, what is x? 0. Look at here. If we know that y is 1, so that means we don't care. If we look at this table, if y is 1, 100% the chance will be here. No chance x will be 1. So expected value should be 0. Now this one, we consider the expected value of x given y, take expectation as a new random variable z. So previously we know that the expected value of x given y, if y is 0, then the expected value will be 0.66. And if y is 1, the expected value is 0. Okay, these are based on our previous study. Then what? We actually have a new random variable z with this table, or we can say that z is basically 0.66 with chance 0.6 and z is 0 with chance 0.4. So this is the table. With this in mind, then we can now compute what's the expectation of z, what's the variance of z, okay? So the expectation of z is very simple. This number times this number plus this number times this number. It will be 0.66 times 0.6, it will be 0.4, okay? And here is an interesting thing. We have ez equal to 0.4. Notice that ex is also 0.4. So this is saying that this is 0.4, this is also 0.4, but ez alone is expected value. So that means expected value of another expected value of x given y is 0.4. Expected value of expected value is, in this case, we have this. This actually is a formula in expectation. We won't go too deep into this, but I'm just showing that this is true. Now, what's variance of z? By formula, we can compute using expected value of ez squared minus the ez whole thing squared. This is the expected value of ez squared. This is the expected value of ez whole thing squared, which we just used from here. Okay, so this will be the number.